Now we're going to look at the applications of factoring, solving equations of high degrees. High degrees means that the equation has x squared or x third or x fourth. Okay, so let's look at the review the steps of doing solving equation with high degrees. So the first thing we want to do is to make one side 0. And second step is to factor the non-zero side. The third step is set each factor equal to 0 and solve. Well, we have talked about this before, and just a quick review. The reason why do we have these 3 steps? Because this is based on a very simple property. If the product of 2 numbers is 0, then one of the numbers must be 0. So let me put the property down here. So the property says if the product of 2 numbers is 0, then one of the numbers must be 0. 2 numbers here actually could also be 3 or more. So based on this property, we first have to get is 0 means E equals 0. So that's why we make one side 0, because in the property says is 0. Then why do we do the second step, factoring? Because it says we have to have a product. And factoring exactly helps us change any expression to a product. And by the conclusion, so if we do have that one side factored in product, the other side is 0, then the conclusion is one of the numbers must be 0. So that's why in third step we can set each factor equal to 0 and solve. There should be a solve right here. Okay, so now we're going to look at the first example. 9x squared equals 6, following these 3 steps. Again, if you remember this property down here, if the product of 2 numbers is 0, then one of them must be 0, and you know which steps you should do. So first of all, I have to make one side 0. So we're going to subtract 16 from both sides, because we want to make one side 0. So now we're going to get 0 on the right side. The left-hand side, notice that they are not like terms. We cannot combine them. So don't subtract 16 from 9 because they're not like terms, or because 16 doesn't have a variable, but 9 has a variable. Okay, so now we are going to do the we finished the first step, make one side 0. Now we're going to do the second step, factor the non-zero side, which is the left side. Now we're going to check which type of factoring this is. So far we have 2 types. GCF, this apparently is not, because there's no greatest common factor except 1. And now we're going to check the second type, difference of 2 squares. We do have difference. And notice 9 is 3 squared, 16 is 4 squared. So we can, although it's not in the perfect square form, we can rewrite this as 3x squared, because we raise 3 to the second power, we're going to get 9, and then raise x to the second, we get x squared. We're also going to write 4 as x squared, 4 squared, and keep the bring down the equal sign to 0. Now we're going to use the difference 2 squares formula, and 3x squared means 3x times 3x. So we're going to do 3x here, parenthesis, times another copy of 3x. And next we want to get the minus sign. So we put a plus times minus. Next we're going to get 4 squared. That's 4 times 4. So we finished the second step. Again, bring down equal sign to 0. Third step says we should set each factor equal to 0. So we're going to set the first parenthesis 3x plus 4 equal to 0. Or, because the conclusion says one of the numbers must be 0, well, it could be the first number, 3x plus 4. The first unknown number is 4. Or the second, 3x minus 4, is 0. So the first number is 3x plus 4 is 0, or the second, 3x minus 4 is 0. Now we're going to solve each one. Don't stop here because we still need to find out, get x by itself. So we're going to subtract 4 from both sides here, and then we're going to divide both sides by 3. So 3x equals negative 4, and divide both sides by 3. We're going to get x equals negative 4/3 if the first parenthesis is 0. Similarly, we're going to get this x by itself by adding 4 to both sides, and then we're going to divide 3 both sides, and this time we're going to get a positive 4/3. So we have two solutions, negative 4/3 and positive 4/3. In the second example, we've still followed these 3 steps here. Make one side 0. In this case, the right hand side is already 0, so we can skip the first step. Now we're going to factor the non-zero side. And notice that they do have a greatest common factor x. So let's factor out x. And after we factor out x, and we are going to get x squared minus 4. If you have trouble seeing how we got x squared minus 4, do division, because you pretty much take x third divided by x. X third divided by x is x squared. And we take negative 4x divided by x, that gives us negative 4. And equals 0. Bring down equal sign to 0. And now we continue to see whether we can factor x squared minus 4. And notice it's difference of 2 squares. Again, we should be able to factor it further. So we bring down that x, and we're going to use difference of 2 squares. As you can see, 4 is 2 times 2. So x squared is x times another x, and minus is going to be plus times minus, and 4 is going to be 2 times 2. So now we bring down equal sign and 0. And now we can do the third step, set each factor equal to 0. This time we have 3 of them, so we're going to set each one. The first one, x equals 0. Or the second one, x plus 2 equals 0. Or the third one, x minus 2 equals 0. So the property I put down here, notice that you can have more than 2. So x minus 2 equals 0. Now we have to solve each one. Notice the first one is already, in this first equation, x is already by itself, so we don't have to do anything. The second one, we can subtract 2 both sides to get x by itself. So we get x equals negative 2. And last one, we can add it to both sides, and we got x equals positive 2. So there are 3 solutions. And now let's look at the last example. Again, following the first step, we're supposed to get one side equal to 0. So let's subtract 27m, make the right side 0. If you want to make the left side 0, left-hand side 0, you can also do that. So we subtract 27n. Notice 27n minus 27n will become 0n, which is just a 0, because 0 times n is 0. Bring down the equal sign. The left-hand side, because they're not like terms, one of them has an n squared term, the other does not have a square, which is just 27n. They're not like terms, so they cannot be combined. So we're going to do the second step, factoring. Notice they all have a 3n in common, so we're going to factor out, do GCF first. We're going to factor out 3n times n minus I guess I just noticed that we're supposed to have a third power here to make it a similar question to the homework. So let me change it a little quick here. So this should be a 3n cubed. And so they still have a 3n in common, so we factor out a 3n. That would give us n squared minus 9. If you have trouble seeing why we got n squared minus 9, you will take each of them here, divide by the greatest common factor, 3n. 3 divided by 3 is 1, n cubed divided by n is n squared. And then you take negative 27n divided by 3n. 27 divided by 3 is 9, and n divided by n, they cancel out. And when we get here, we keep 3n, but n squared, notice it's difference of two squares again, and because 9 is 3 times 3. So we're going to get n times n. In order to get n squared, that would be n times n. In order to get minus, that's going to be plus times minus. In order to get 9, it's going to be 3 times 3. So that's the difference of two squares, equals 0. So we can do the third step, set each factor equal to 0. We're going to set the first one, 3n equal to 0. Or the second one, n plus 3 equal to 0. Or the third one, n minus 3 equal to 0. And notice we also have to get each n by itself. So these are three different equations. We have to do one by one. So in the first one, 3n equals 0. We can divide both sides by 3. So we got n equals 0 divided by 3, which is still 0. The second one, we subtract 3 from both sides. We get n equals negative 3. The third one, we add 3 both sides. We get n equals positive 3. So there are three solutions. So usually a quick check is if the highest exponent is 3, then we should have 3 solutions. If the highest exponent is 2, we have 2 solutions.